At this moment, I would like to shift the focus a little and potentially delve into your responsibilities as the head of battery testing in more detail. Furthermore, it is of utmost importance that you make arrangements to set up a test laboratory, as this is a substantial factor that cannot be overlooked. A laboratory for testing batteries to truly support the development of ElringKlinger. And I find that naturally super interesting, because I am naturally also involved with laboratories for battery testing. And at that point, it would be incredibly fascinating to engage in a small talk and delve into it a bit more, as it holds great interest and curiosity. Certainly not to disclose any internal details. However, what were the most significant obstacles in the process of planning and establishing such a laboratory?
To answer well, I think describing the starting point for us also makes sense and is necessary. ElringKlinger, of course, a traditional company in the field of combustion technologies with cylinder head gaskets, shielding parts, plastic components, oil pans, has always been very well positioned in its own testing capabilities. Furthermore, ElringKlinger has managed both ElringKlinger Motortechnik in Idstein, which has a considerable number of engine test benches, and its own engine test benches at the primary site in Dettingen under arms at the company's headquarters. And when the turnaround started, many years ago, over 10 years ago, ElringKlinger provided the initial contact animal system for BMW, at that time for the i3. You could reiterate that it is necessary to establish internal capabilities for contemplating advancement, and to some extent, the driving model and development stages in the automotive sector. It is crucial for a company aiming to ultimately manufacture as a supplier of components, parts, and now systems, serving as an end customer, such as an original equipment manufacturer, OEM, or Tier 2, to have their own set of resources, particularly during the initial development phase of the project. And precisely with the mindset, so 4 years ago when I assumed the responsibility, they possessed a battery tester. So, during that particular time, in the climate cabinet, equipped with power electronics designed for round cells, the current was limited to only a few amperes. And the task at that time was to establish meaningful testing. So that was the entire task formulation. So not any more and not any less. We talked about a large number of concepts. One has thought about it, let's found our own. So analogously to Ringklinger Motortechnik GmbH, our own battery testing lab. One has carefully considered the optimal size of the in-house test field and the most effective design approach to implement for testing purposes. Does that mean, are there a few square meters or many? Ultimately, we now have a test field of almost 2,000 square meters, but it is highly specialized. I appreciate the comparison with the toolbox and the handyman. We have a wonderful opportunity here in the newly established locations in Leuven, situated in the district of Esslingen, to conduct very specific tests and gather valuable insights. We possess cell testers, module testers, pack testers, as well as shock vibration systems and climate chambers, enabling us to perform targeted testing at the component level. However, the major challenge, which was indeed the initial question, was truly to determine the size of the entire thing. So what is the setup in terms of strategic alignment? How much in-house? How much external? And there were many discussions at the end of the day with the responsible component developers and system developers who provide us the specs, what should be secured. On one hand, we have the norms landscape that provides us guidance. For instance, there was also a definite decision not to carry out destructive tests in-house because one aspect is to acquire the equipment, but another aspect is to acquire the experts. That means here we have stated we prioritize the development of the entire function. This encompasses all aspects, including cooling circuit, performance, cycling, and component level protection measures. So, in the meantime, ElringKlinger is also in the situation that we are conducting hard turn loop testing, so control unit, safeguarding, because of course we also have the responsibility for functional safety from the battery storage. Exactly, so that was actually the biggest challenge, to find the right setup for ElringKlinger that also fits the product group strategy. And from time to time, there were of course external influences, such as being able to obtain test capacity options on the free market at certain times. We also exerted a partial influence on the decision in the end, or on the final result.
What are the initial steps in that location? Because ultimately it is undoubtedly a pleasant and comprehensive picture that emerges with the testing capabilities and having all of them located in the building. However, especially when you start from a relatively untouched and undeveloped area and say, I really have an urgent need to get something operational on the road right now. I require a laboratory that is internally consistent, coherent, and maintains cohesiveness within its own structure and operations. That is precisely a challenge, especially when you produce an insane amount of products. It is not as if Elrin Klinger is currently involved in car production in any way, shape, or form, and you have a precise understanding of what is to come, but it is also a supplier that delivers components to a diverse range of products. And there is likely also the challenge that the requirements are quite variable and can change significantly over the course of the development period.
Absolutely, exactly. Yes, the initial point of departure is indeed so you do not undertake it in solitude or without assistance from others. That is already very important. You require a strong team. And there I had probably also luck, yes, definitely luck, a good core team with which I could start off. That means there were a total of 11 individuals present at the beginning of the designated time period. Of course, there was day-to-day business, project support. This is also the challenge. One must serve ongoing projects. During that period, we conducted external tests on 90% of the components and gradually transitioned to the new tracks one by one. That means I have established a small project team consisting of 2 employees who subsequently prioritized gathering the requirements initially. During a 6 to 8 month period, we thoroughly analyzed the market to assess the available technical solutions and their suitability for our needs. We have collected a few rows. What requirements do the projects have for tests? The main focus of the discussion was on the topic of performance issues, specifically related to cycling. That signifies it has obtained a considerably substantial proportion. How do you evaluate the battery accurately in terms of its cycling capability? We have also established a list early on of the items that are not within the scope, so we can clearly define what we do not desire to have as internal testing options in the first 1 or 2 years of the project. That means we've also set up a roadmap where we said, okay, priority 1 was actually performance, because those are elaborate tests, a lot of pre-development tests. We have addressed the topic of BMS drivers, which means data generation for the parameterization of control units. These are essentially core competencies that we had identified for ourselves, where we said we need to focus on, and that was the initial phase. This indicates that with this spectrum, which is presently approximately 500 to 600 square meters of our space, is utilized for cycling, functional development concerns, everything related to quasi-electrochemical characterization. And then we started running. And with this, yes, with this list of requirements, we went to different ones, which of course have grown a bit beyond the different status, because a lot has already been discussed technically in an early phase. And you truly have to state extremely positive, consistently extremely positive experiences with all of the typical manufacturers of battery test benches that are available on the market. Open communication from start, advised, partially supported in strategy finding, provided insights on how it's solved elsewhere, current solutions, and future solutions they will work on. Very helpful in understanding different approaches and their plans for improvement. The spectrum was very broad, and after a duration of 8 months, we had a comparatively clear picture regarding this particular performance issue.
Yes, precisely. However, truly considering the focus, what holds strategic significance? What do we actually require to support development as effectively as we possibly can, right?
Exactly. So we have also separated from the start, mentally distinguishing between battery system, cyclicality, electrochemical characterization, and the component business, i.e., components, which refers to the different parts involved. We also organized that as a second team right from the beginning. That means even today we are divided into 3 teams in the experiment. And one team is solely responsible for the problems related to electrochemistry, and another team is responsible for conducting component tests such as housings or control unit elements, HVJB, or time contact system. And through this separation, it has of course simplified a bit because the complexity is actually in the battery cell testers or battery testers.
Additionally, the procedure for operating these testers and their interaction with the climate chambers, as well as the methods to ensure the attainment of a meaningful result, need to be understood.
Once again, one always realizes when talking to battery test experts and using the word test bench. What is a test bench for someone? We often have discussions, even when we test externally or talk to development colleagues here. For us at Elring-Klinger, a test bench is actually the entire setup. Climate chamber plus power electronics plus measurement technology. This is how we classify a test bench. At the end of the day, they are naturally modular structures, as you rightly say. However, the connection is made through the security questioning. This means that a standalone climate chamber and standalone power electronics without a safety matrix in the background do not fulfill the purpose for battery testing.
Prototypes don't require it, at least not.
Exactly. So you have to think a lot about the security requirements, of course, without any doubt or hesitation. Ensure secure setup of the laboratory, including the utilization of safety facilities. That also takes a lot of time. Requires, especially since a fire extinguishing technology was already implemented at that time through the cell tester in use, which was nitrogen inert at that time. However, we were also aware that if we want to operate chambers with volumes of up to 30 cubic meters, which are currently in use, nitrogen inertization is not the appropriate choice.
You expel the nitrogen gas, causing it to dissipate into the air, and unfortunately, all the money is lost in the process.
On the one hand, from a business perspective, if you imagine forgetting something, or there is a problem with the test specimen, and you have to repeat the inertization process up to 3 times before you are ready for testing again, that is almost a no-go from a business perspective. But you also have to consider employee protection. So if I possess a nitrogen-flooded chamber having a volume of 30 cubic meters and there exists a leak, I additionally possess a safety risk for my employees.
Yes, definitely, absolutely, without question.
So here, of course, there are also many solutions on the market, but again, a big challenge was the selection and setup of the right security devices, extinguishing technology. I believe that anyone who tests batteries today will agree that it is not a question of whether something happens, but rather a question of when something happens.
Indeed, in that case, you must be prepared for it. Upon reflection, what were the most valuable insights that you or the entire team essentially gained during this setup and preparation process? Or how would one approach things in a different way today?
In fact, we accomplished many things correctly. Therefore, it is also an opportunity for learning. We actually took, even though it was sometimes lengthy, so a total of 8 months. Now some will say, how can you take such a considerable amount of time to choose something that is correct? The time was opportune and precious for us. We have recorded it. We have also coordinated other adjacent departments with integrated procurement processes again. That means other areas have also grown along with this learning curve. It is already the case that we also document it cleanly and also like a purchase. And a purchase must rethink. He is no longer buying production facilities, but he is buying R&D test equipment. This has additionally been a fresh domain for Erin Klinger to some degree, presenting a new and unexplored area of expertise for her, where we also learned what we then had to carry out in the follow-up project. We had to carry out a test field extension a year later, which of course went much faster. There was a lessons learned that we need to install a project management, so we tried to get a general contractor, especially to bring together this conglomerate of climate chambers, power electronics, measurement technology, and safety equipment. For example, in the second procurement package, there was a shock vibration test bench that also has a climate chamber, which has the same extinguishing technology. Following that, we had numerous discussions in the initial phase regarding the party responsible for the security control as well as the definition of the security rules that needed to be established. Certain manufacturers in the market still face challenges in taking responsibility for this. That means for us, lessons learned was from the first round, we are installing a central project management. We do not rely on the supplier. Thus, that is not meant to be mean or unkind in any way, shape, or form. We have simply learned for ourselves that we cannot fully delegate this responsibility to the suppliers.
And even then, an individual still needs to inspect it and validate all aspects regardless. Then you have to put in the resources anyway.
However, we currently insist in our specifications that our contractor must provide a central project manager without any ambiguity. Lessons learned in our specs that we hear are also important. Demand clearer responsibilities. I think a spec sheet can always be formulated as precisely as possible mentally, and once it's processed, one realizes there was still some uncertainty at some point.
Yes, that is indeed true, and that is always the specific point where sudden additional demands arise, and where one inevitably gets lost in lengthy and often unproductive discussions that seem to go on forever.
In which we actually had, that was once again a positive experience for us, due to the fact that we also had very intensive discussions prior to the commissioning. During development of our requirements with partners, there were changes and discussions, but these always took place on an equal footing. So this is also important because a project can quickly come to a standstill if you get lost in details, trivialities, and inconsistencies. So there we have with the partner, as can also be read in the media, with whom we have tested, I have to say, always discussions at eye level, being able to work very solution oriented. Certainly, that also assisted us in constructing the foundation of what we possess at present.
Yes, so I believe if you have the right partners on board, that can accelerate things and vice versa. If you have the wrong ones, then you can really get lost in detailed discussions and nothing moves forward.